Hey again, and welcome back. Today it's time for a kit build. It's been a little bit since a kit build, so yeah, it's time for it. The only problem is I'm not sure what this kit does. I believe this is a relay. I think so. 5-volt DC. Yeah, I think this is a relay. So it's some sort of switching device. That's you know one one thing to look for. Um, I've got over here. This is an LDR, a light dependent resistor. So this resistor will change its resistance depending on the light level. And this is a LM393. I'd have to look that up, but I think it's an op amp. Not sure though. But I figured we'd put this together, and I don't know if we can't figure it out. We can't figure it out, but if we can, we will. So I like to start with the low profile components. There's a few resistors here. Got two 10Ks that look right. Yeah, two 10Ks. So I'm gonna grab these. I think these are the 10K. Let's see, brown black. Brown black is 10, and orange would be a multiplier of uh, like 1,000. Yep, 10 and orange. So these are the 10Ks. If you weren't sure, you should probably meter them, but I'm reasonably sure, and what would this channel be without me making mistakes on kits? So there it is, brown black. Is that 1K? I just put that in the 1K slot. It's starting very well, ladies and gentlemen. Pull this guy out. 10K over here. Okay, two 10Ks. I think there are three 1Ks. One there, and one here. 1, 2, 3. I believe these are the 1Ks. That's brown black. That's 10. And then red. 10, two zeros, 1K. Put these guys in there. Some people don't like spreading the legs on these components because it kind of puts it at an awkward angle. But I like them to hold on by themselves. You can use, like, I know Julian Eilert uses sticky tack to just hold them in. I use sticky tack to kind of hold the board. So there's 1K, and last one. Over here. There we go. Now we've got two diodes. We've got one over here. I don't know if you can see. One over here and one over here. There's our diodes here. These diodes are 1N 4007. And they have a direction. They're polarized. So typically, yeah, see the arrow points down? Means the band is going to be on that side. They have nice thick legs on these things too. 1 and 2. So again, arrow points that way, so the band will go on that side. There we go. And we also have one more resistor. It's a 4.7K. And we do have one resistor left. And what is this? This is yellow, that's 4, purple, that's 7, and then red, 2 zeros, so 4.7K. I much prefer 4-band or 5-band to 4-band resistors, but you gotta use what you got. Okay, move these aside a little bit, and then place this down. This is where I use the sticky tack. Hold down the entire board, which gives me a nice surface to push on. So I'm using 6337 lead solder. Lead solder, again, not that bad for you. Just gotta, like, not lick your fingers directly after handling it. There we go. That stage done. I'm going to take a look at the solder a little bit closer when I get a second. Alright, so what's next? Guess we could do pin headers. So pin header here. These pin headers you cannot bend, so I will use sticky tack on them. So that's pin headers there. There are pin headers here. JMP2. Like that. And I guess we'll put our socket in. You see the little alignment hole down there, or up here I should say. Put our little socket in. There we go. I never use any one of these sockets. I usually use like solder ICs directly to the board. Maybe I should start using sockets though. Makes things a lot easier if you want to just remove things. Let's see, and I think they're very inexpensive too. Over here. Over here. Put a solder here. You get that. Just want to flip the solder away. Some places have a bit too much solder, some places not enough. But it typically doesn't matter. It'll typically work anyways. If you're doing some really precision stuff, it really needs to work first time every time. Be very careful, but if you look here, there's like a ball of solder here. It's not too much to be worried about. Right here too much. I solder a lot better when I don't have a camera in my face. Whether you believe that or not is up to you. Alright, so not too many components left. We have a transistor. You can slide into here. This is a 8550, and what do I have here? S8550. Yep, that's correct. Looks like the flat is this way. So there we go, that's in there. We have 104 capacitor, 104 capacitor. There should be 2 of these, so there's 104. Like that. Spread the legs out a little bit. Second one here, 104. Yeah, 104, that's 10 nano. 10 micro. or 0.1 micro. That's what it is. The capacitor values are still a little iffy in my head. I still have to look them up and double check them. It's not something, it's like resistor color codes. It'll come eventually, but right now, not so much. So this is 100 microfarads electrolytic. There's the footprint for it, and the negative goes in the hatched area. So like that. That's good. We might as well put our potentiometer, 10K potentiometer. So here it goes in. This is 10K, so 103, so that's 10 with 3 zeros, that's 10K. It goes this way. Only fits one way, which is nice. Fits a bit tightly in there, though. I don't think they have the exact right footprint for this component. But close enough is close enough. We have a jumper here, 5-volt jumper there, but you're supposed to just solder wires because they don't give you any sort of attachment method. Okay, so here goes. Only a couple more components now. We got the relay. The legs are all weird on the relay. That's what happens when they come all the way from China. Okay, and then these screw terminals. That and these screw terminals. Clearly from different batches, they have different blue on them. Here we go. And we'll put the diode in. I guess we'll put the diode in now. So flat side towards negative, long leg towards positive. And the LDR, why not? I was going to stick this one out a little bit. Just going to flip that over like that. I want to keep it in place because the LDR, I want to be able to point it to wherever I want it. So I'm not 100% sure what you just finished seeing because I ran out of record time on my camera. So everything went black at some point and I don't really know when. But this is all soldered together and ready to go. I think I didn't miss any solder points. Oh, hope not anyways. When I finished, I took a look at the data sheet, or I guess a listing, I should say. I didn't really look at the data sheet. For this LM393, it is actually a comparator, not an op amp. You can use an op amp as a comparator, but this is a specific comparator, and that makes sense. It's going to compare one divided voltage, which is divided by this resistor, compared to this sensitivity wheel probably. And I'll put that in. And I also, I guess it's a little bit of pain in the butt, I also looked up the different jumper positions. So I have a better idea now of what's going on with these jumpers. I'll go through that in a second. Let me just struggle with this for a bit. There we go. That's in. Okay, so over here you have position 1, 2, 3, 4, and that is for the trigger mode. So this is jumper 1, yeah, JMP1. So if you want the relay off in the dark and on when it senses light, then you put the jumpers on 1 and 3. And if you want the relay on in the dark, off in the light, put the jumpers on 2 and 4. So we want them on in the dark, off in the light, because right now we're in the light. So we'll put it on 2 and 4. So there's jumper on 2. There's a jumper on 4. Like this. And then relay on or relay off. So relay works or it doesn't by jumper. So we want it to work. So 1 and 2. So there's jumper 2, 1, 2, 3. We'll jump 1 to 2. Like that. Okay. This is a 5 volt DC device. So I'm going to use my Pick Quick Multic here to... Oh, I guess I don't have a flat screwdriver small enough. I was going to use a Phillips, but these holes are Phillips and these are flat. So, moment please. A little bit better. So I have a pegboard sort of that way. But it doesn't always, it's not always convenient. Some stuff is just not that great in a pegboard, or it just takes up a lot of space in a pegboard. Like screwdrivers, for example, would take up a lot of space in a pegboard. So I'm just putting positive and negative here. This is the input. It is 5 volts. So I have my adjustable power supply here. Set down to 5 volts. So theoretically, there's 5 volts, set. Okay, so theoretically we should be able to turn this on and nothing will change. And you see there's 3 terminals here. That's because one is common. I'm not sure which one. One is normally open and one is normally closed. So I can see that normally open is here, which I have to figure out where the common pin is. And to do this, you just go on continuity check and move this into frame. That would help. So this guy and this guy, I'm assuming. Yeah, hear the noise. Okay, and then which one is the common pin? I'm guessing that the common pin's in the middle. It just makes logical sense. So that those two are connected. So what I will do is I'll swap these leads out with something that a little bit more friendly to these screw terminals. So we know that these two are not connected. And like one here, these are not polarity sensitive. They shouldn't be, at least. One there and one there. And so since these are not connected, we should be able to power this device up. And the multimeter still will not beep because it is under the light. It should work. And then once I cover the sensor, then it should click over and this should beep. So let's take a look here. We'll go, okay. No, it clicked over. Maybe this here, maybe this jumper is wrong. This one is wrong. I think if you remove this, that's odd. All right, let's try. Oh boy. Okay, let's try changing the sensitivity here. That's odd. Okay, let's turn that off. Interesting. I wonder if the other one is... if it's supposed to be this one here, not the center one that's the common. Doesn't really say on the silk screen. So I thought the middle one was the common. Let's see if it's actually changing anything. Nope. Okay, so this middle one here is the common one. Yep. And I'll just turn off the buzzer. So the middle one is the common. So now how do we get this? Just make sure relay is off in the dark, on in the light. Relay is on in the dark, off in the light. So 2 and 4, we are on 2 and 4. Relay on 1 and 2. So that makes sense. So it should be off in the light. So we need to turn this until it turns off. But it's not really letting us. Interesting. I wonder if something went wrong here. It's always possible. Okay, let me take a look at this circuit just to make sure all the soldering is fine, and then I'll bring you right back. Well, I actually have no idea. The soldering, I touched up a couple spots, but really it was still making electrical connections, so it should have been fine. But either way, I still can't get it to work. So right now we've got the jumpers in 1 and 3 positions, and 1 and 3 should be off in the dark, on in the light. So right now it's in the light, so it should be on, but I cover this and you see the LED stays on, and no amount of changing the variable resistor does anything. Also, this jumper here, which lets the relay turn off or turn on or not, I can put it in no jumper position. Still, we can't get it to turn off. Well, right now, actually, we can't get it to turn on. Whether I cover this or not, nothing's happening. If I put it in the relay disabled position, it makes sense that it wouldn't do anything. So all the way either direction, and also if I cover the sensor, making it dark. So that's not good. And again, I can repeat the same process with this in the other direction. So the jumpers are now on 2 and 4. Okay, with the relay deactivated. Nothing I can do will turn it on. Cover the sensor. Still not turning on. I can take this guy out completely. So again, full range. Not casting any shadow on it. Block the sensor. Nothing's changing. And then put on the relay on position. Relay clicks on automatically. So sensitivity adjustment does nothing. I block the sensor, change the sensitivity, does nothing. So basically in every single jumper position, aside from just leaving these things off, I guess. 1 and 2, there we go. They are gone. And still can't Move the relay. So I guess I'll have to go to another video where I'm going to actually draw out the circuit for this, try to figure out the circuit, and then diagnose this board to see what's wrong. It could be me. It could be a faulty design. It could be a faulty component. I did already try putting another LM393 in. Didn't change a thing because I actually have two of these kits. So if you're looking forward to that, make sure you are subscribed. And otherwise, thanks for watching.